Projectile motion. An example of projectile motion would be me throwing a baseball to my sister. It's a two-dimensional motion because the ball moves in both a horizontal and a vertical direction. In the horizontal or x direction, the ball doesn't slow down in the absence of air resistance. That means that its velocity stays constant throughout the motion. Remember that acceleration is the change in velocity over time, so if there's no change in velocity, the acceleration in the x direction is 0. In the vertical or y direction, the ball is being accelerated toward the Earth with a magnitude equal to g, the gravitational acceleration value. We use 9.8 meters per second squared for this value. These define projectile motion, 0 acceleration in the horizontal direction, and the magnitude of the vertical acceleration being equal to g. Since the gravitational acceleration is the only acceleration that an object is undergoing in projectile motion can be considered a form of free fall. And since projectile motion is a two-dimensional motion with a constant acceleration, we can use the two-dimensional kinematic equations to solve these problems. Let's look at a classic projectile motion example problem. An airplane is flying horizontally with a constant velocity of 125 meters per second at an altitude of 1100 meters. The airplane drops a package that falls to the ground along a curved path. If we ignore air resistance, how long does it take for the package to reach the ground? What information does the problem give us? The airplane is moving with a constant velocity of 125 meters per second, so when the package is dropped by the airplane, it is moving with the same value as its initial horizontal velocity. Since we're ignoring air resistance, this is also its final velocity. We'll say that to the right and to the upward are the positive directions. The height that the package is starting at is 1100 meters. Since the direction of the vertical displacement of the package as it falls is downward, and our positive direction is upward, the vertical displacement y has a negative value. Since the airplane is flying horizontally, the package has no initial vertical velocity. And as the package is dropping, it has a downward acceleration of 9.8 meters per second squared. Again, since this acceleration is downward, it has a negative value. The package falls along a curved path in projectile motion as the airplane continues on. Next, what are we looking for in the problem? The time it takes for the package to reach the ground. Now we need an equation. Since this is projectile motion, we can look at our table of two-dimensional kinematic equations, and we find this one that contains our known values of v1y, a sub y, and y, and our unknown value of t. Since v1y equals 0, we can simplify this equation to y equals 1/2 a sub y times t squared. Since we're looking for t, next we go through the steps to solve this equation for t, and now we can plug in our known values. And using our calculator to solve, we get a value of 15 seconds for how long it takes for the package to reach the ground. Throughout the motion of the package, its horizontal velocity remained constant since we're ignoring air resistance. Since the airplane was also moving at the same constant horizontal velocity, the airplane remained above the package as the package fell. The package initially had a 0 vertical velocity, but due to the gravitational acceleration, its velocity increased on the way to the ground. Notice that since we were looking for the time it took for the package to drop vertically, we didn't need to worry about the horizontal motion at all. This is another example of treating the x motion separately from the y motion.